and then we'll start the episode in a couple minutes. We also need to do a sync clap. So basically, what's going to happen is I'm going to count like 1, 2, 3, and then where 4 would be, we're all going to clap into our mic just to sort of give a spike of audio, and that helps them sync everything up. It's going to seem slightly out of sync because of Zoom, but it does help them, or that's what they tell us. So we do it. All right. So is everybody ready for that?
Yes.
Ready to clap.
All right.
Ready to clap. Been working my whole day for this.
All right. 1, 2, 3. All right. Should be good then. And if it's not, well, we can't do 2 claps. We've learned the hard way. That doesn't help them. I think we had one episode where we tried to clap like 4 times because Matt kept trying to start from 0. And even as programmers, we can't start from 0.
Live on the audio only stream too.
I don't have the audio only stream up yet. I am getting that one now. Sorry, I have to like open a million pieces of software to make all these things happen. You're always making me do the audio only, Chris. I'm gonna tell people we're shutting that one down.
We already got 2 listeners. See?
The worst part is the audio only one is it's hard. Even if I wanted to get rid of it, it'd be hard to, because when people start commuting again, it ends up being really useful for that. I think that's where a lot of people tend to like it, is the minimal bandwidth setup.
Instead of
Okay, are we?
A bunch of video.
Okay, we're actually live on YouTube. I'm not going to make the same mistake as last time. I swear last time I clicked the button and it like grayed out, and then it just like never did it. And I was like, awesome. Okay, it is after 3. We're allowed to start. Is everybody ready?
Yeah.
Any questions or anything?
Let's do it.
Hello, everybody, and welcome to Go Time. Today, Chris and I are joined by Daniel Selans and Steve High to talk about event-driven systems. Hey, Daniel, how are you?
Doing all right. What's going on?
Not too much. Just excited to learn about event-driven systems from you guys. Steve, how are you doing?
I'm doing great. Thanks.
Awesome. And Chris, how are you?
Pretty well.
Okay. So, Daniel, why don't we just start with a little bit of background information about yourself? What experience do you have with event-driven systems, and why are you sort of the person to talk about it?
Well, I don't know if I'm the exact person to talk about it, but
or a person to talk about it.
Yeah, I'll take that seat, the king of the castle seat. Yeah. So I've been in the industry for about, I don't know, I don't want to age myself too much, but it's been like 15 or 20 years. I've worked in like all kinds of, various places. I have a pretty serious background in data centers. I did a lot of, back in the day it was known as systems integrations. And now it's really just like automation stuff. But after that, I spent a lot of time in like fintech and design space and kind of all over the place, including APM space as well. Most recently, I was at a social startup called Community, where it had the best event-driven system I had ever seen. It was, they managed to pull off something that is fairly rare, which is a tiny startup implementing an amazing foundation so that as they continued growing, they didn't have to patch a bunch of holes. Yeah, I ended up, I've been building event-driven systems for a while, but we started playing around with Kafka between me and my, now co-founder, just somebody I was working with, a community as well. And yeah, we just we came up with this prototype of like an idea as to how like we could basically simplify event-driven systems in the first place, and ended up submitting that to Y Combinator just kind of for fun. and then thought that it was a fluke when the interview came up, and then we're like, oh, well, I guess this is real. So ended up getting accepted into Y Combinator, and then it started, on our trek to basically build this stuff. But at the core of it really is that I've been exposed to event-driven systems for a long time, and now that I'm actually working on it full time, it is more apparent than ever. It is still an area that is kind of it's kind of unknown, right? Like, and people are generally afraid of it, that sort of a thing. So I'm here to really try to kind of like clear the space, clear the air, that sort of thing.
Cool. And your startup is Batch, which is at batch.sh. So do you want to give like a quick elevator pitch as to why somebody might want to check it out?
Sure. Yeah. It's basically, we are a data pipeline company, essentially, that specializes in extracting data from message buses. And we work with basically anything, any message bus tech. So it could be Kafka, Rabbit, NATS, AMQ, let's see, AWS, SQS, and the list goes on and on. We're basically like message bus agnostic. Yeah, if you don't necessarily have to do event-driven, as long as you're doing something with message buses and the data that's on them is important to you, and you need to look at it and be able to inspect it and that sort of thing, then you should definitely check it out. Or just like shoot me a message and see, and we could just chat about it. So
awesome. Steve, how about yourself? What is your experience with event-driven systems?
So currently I'm with a company called Network, which is a it's kind of billed as the QVC for Gen Z, which basically means that we drop really high demand products at a given time, and an entire, a whole lot of people, kind of a thundering herd of people try to buy these things all at the same time. So the event-driven stuff that we do right there is there's a lot of transactional management that we have to worry about, a lot of state management that we have to worry about. Previously, I was with a few other companies that had simple, or not quite so simple, message buses using Kafka and QTT and other types of technologies like that. But going back even further, my main background is actually embedded systems design. So message buses in that sphere look a little different than they kind of do in the current flavor of technology, but at the end of the day, it's kind of the same concepts. So it translated pretty nicely for me to move all that knowledge to where we're currently at with an event-driven microservices architecture.
Awesome. You've both mentioned some different technologies. Would one of you like to take a stab at just sort of explaining at a high level what an event-driven system actually is?
takes it, Steve. Me or you?
Okay. How about you first, and I'd be your hype man?
Sure, sounds good. I love it. All right, so I'm going to try to do it in a non-scientific way, but really at the core of it, it's a systems architecture that essentially requires you to, or it uses asynchronous messaging to communicate state, usually asynchronous messaging to communicate state. And that basically just means instead of a service A talking to service B directly via REST or gRPC or whatever, instead you're emitting a message saying that some sort of a state change occurred, and you do not know in advance the audience that actually it's intended for, but somebody's going to consume that message and do something with it. Honestly, it's a fairly simple concept, but what you end up with is you're gaining a lot of reliability for introduced complexity, essentially. So that's at the core of it. What do you think, Steve? You gonna hype that up?
Yeah. So yeah, basically what Daniel said. I mean, the main crux of it is you are communicating the state of something in your business logic, be it it could be literally anything, a shopping cart or the customer's status, that kind of thing. The key is the coordination. I guess we'll probably get into that in a bit, but the coordination of those events and translating of those events and the tolerance that you have for lost data and that sort of thing. That's really where the crux of the design of the event-driven architecture really where most of the time you should spend on such a thing should take place. That's normally, in my experience at least, that's where most of the time is spent, is dealing with kind of like edge casey failure stuff. But yeah, it's asynchronous events, sometimes synchronous. The receiver really doesn't know where it's coming from. They just know that they got a message. So that's kind of that simple.
Okay, so as like a more concrete example, in let's say I have a system where, I don't know, a user is signing up and paying for a plan, and then that sort of unlocks their account. What would that look like in an event-driven system? Would like you still be talking with services, or would just events be used for certain parts of that?
You would definitely not talk to any services. You would be talking, all the services in an event-driven system usually utilize some sort of a message broker, like an event bus, right? So the idea would be that whatever your front-end app is communicating to a main BFF, like a backend for a front end. That backend for a front end receives the request to charge somebody or something like that, or put it in an order. And what it's going to do is it's going to just emit a message saying that, like, hey, a new order has come in, or something like that. Another service, let's say a billing service, is going to pick up that order because it's listening to those messages, or for that, for, let's say, that routing key. It picks up the message, does something with it. Maybe it emits another message for another service to do something with that message as well. But let's say it charges the person and goes to Stripe and does everything. Then it would emit another message onto the same event bus that the front end app, or like the BFF, is basically listening on as well, and says, oh, it's complete. That's essentially it. And it can get, obviously, the more business logic you have and the more decoupling you're doing, you could have, 5 services actually be working in that. It's you basically build it out as complex as you need, depending on what kind of scale you really need as well, right? It's all growing out of necessity, not because it's the proper way to do it or whatever from the get-go.
So obviously, anybody who's just starting out with building an application or just sort of getting a feel for it, it's going to seem intuitively easier to just talk to the services you need, especially because then you'll know that things have happened. So if somebody was considering this event-driven architecture, what are some of the benefits of doing that like might entice them to try it out?
Steve, feel free.
All right, I'll go first. Yeah. So one of the things is that you'll probably notice immediately, depending on how you've written your service to begin with. But one of those things you'll notice immediately is a performance bump. You will be able to dispatch these kind of dog and pony show things in the background, and then your UI can do things to make the experience kind of seamless for the user. But really, what's happening is you're getting a performance bump from the fact that you are now asynchronously dispatching, hundreds or thousands or even hundreds of thousands of messages immediately, and then the rest of your architecture is kind of delegating those tasks around to handle the disposition of those events. Whereas with a synchronous architecture, it's RESTful, requests, database calls, that sort of thing. You are tethered to your IO at that point. You really can't escape the physical reality that you have this IO boundary around your service. So that's, in my opinion, that's the biggest advantage. There are some other advantages, particularly around in general, the distribution of work, but it also makes it a lot easier to, as an organization, let's say, to create like a common lexicon of types that you can then work from. It kind of forces you, within reason, it kind of forces you to curate those things properly instead of just kind of willy-nilly throw events over the fence, because you have to maintain a discipline to then unpack those events, any observability that you have to worry about, any of that stuff. It really forces you to think about how you're communicating across your stack.
I would say also that a massive benefit from this is you're building a really solid foundation for the future. Instead of having to untether a massive mess from, at some point in time, once your company or whatever your org has grown, and having to basically try to decouple a huge monolith and so on, you already have gone down the right rails, right? You already are decoupled in the first place and so on. But that said, just to put in a slight con, even though I love event-driven systems, it's the fact that they are fairly complex. So it doesn't necessarily mean that every startup should be doing event-driven. They should. There's actually, in most cases, I would say that they probably should not do event-driven for a tiny startup. If you're just doing, a web shop or something like that, maybe it's not necessary. However, if you are planning to build something that has to be high throughput and high scale, it totally makes sense to actually get those foundations right. Like Steve said, I think that is like one of my number one things that you gain out of event-driven systems is speed and performance. Just the simple fact that there is nothing blocking any longer as you're inputting some sort of data. I mean, you still have Kafka or something that's basically buffering all the stuff behind the scenes, but really, now you're essentially limited by how fast you're able to write to Kafka. And that is incredible because a really simple service, all of a sudden, instead of just being able to do 1,000 requests a second, can do 100,000, right? And that's a really big deal. But again, it depends purely on your use case, right? Like, so what are the goals of the thing that you're building? Are the goals super high throughput and scalability, reliability, that sort of thing? Or is it, just a little tiny side project. So
a question on that. It kind of sounds like doing this event-driven type of system would require either low coordination or induce some kind of higher latency for coordination. Like if you have to use Kafka to talk to another service and you need something back from it, you incur the cost of sending things over Kafka. So I guess for either of you, would you suggest that, if your use case kind of skews toward that, you avoid event-driven, or is there some kind of hybrid pattern that you might be able to use where event-driven could help you out?
Steve, it's up to you.
Yeah. So I'm gonna use the cop-out answer for most of these kind of nebulous, not even a nebulous question, but every single one of these questions could be answered with "it depends." And this is definitely one of those times. So if I was instrumenting my services, I would probably measure the amount of time it takes to run that loop versus like a direct connection. And I'd weigh that against the performance load that it puts on, using the event bus versus not using it, what that load looks like. And basically those decisions, those are engineering decisions based on what you're willing to tolerate in terms of customer experience and that sort of thing. So if it was a transaction, let's say where you're making a purchase and your money is involved, obviously the tolerance for failure there is really low, if not non-existent. Whereas if you're just refreshing a page, in the user experience side of things, that tolerance can go up a lot higher. So you basically have to make those value judgments. Normally, there's probably some mathematical formula that somebody came up with at some point, but I normally just base it on starting with user experience and work my way back. What can a user tolerate before they either close the web page or put your app down?
I'd also mention, by the way, that so first off, it depends is a pretty sweet answer. It's totally true. So, but I think for me also, like when I'm looking at this sort of stuff, it depends on the number of events that you expect in there. For a particular transaction to take place, if you are expecting there's going to be 100 events that need to be exchanged, well, besides the fact that maybe you haven't quite architected it correctly, at that point, maybe it doesn't quite make sense to do that, right? At the same time, if we go down on a slightly lower level, on a technical level, the difference between creating a connection to some HTTP service versus a pre-established connection to your event bus is going to be faster on the event bus 100% of the time, always. So you creating 6 connections, one after another, to various different services, plus you have circuit breakers, like Hystrix style circuit breakers or something like that in place, it's guaranteed going to be slower than you emitting events, right? So I think I think generally speaking, if you're doing under 50 events to or let's say even under 20 events to to perform some sort of a transaction, I think it's fine, and it's generally negligible in comparison to like some sort of a RESTful call, right? That you're, sending to some whatever service. So,
can we take a step back 1 second? Daniel, I know you mentioned that batch works with pretty much any event bus, but
yeah.
it just like dawned on me that everybody listening might not quite know what an event bus is. So like at a high level, could we just sort of make sure that they're, on the same page?
Totally. Yeah. An event bus is really just a fancy word for a message broker, which is really a fancy word for a queue. So queue with different kinds of capabilities. Basically, it's a centralized system which accepts messages, queues them up, and sends them to consumers, right? That's essentially it. At the core of event-driven tech or event-driven architectures, there's always a message bus, and message bus versus event bus, like I think it's synonymous, really. And you can really use. We've seen as we've built batch, we've seen people using everything. That's the reason we actually we continued building out batch towards the support of all these different systems. Not because we were a bunch of geniuses who are like, oh yeah, we need to add support for like this and this. No, because people were asking for it, and we're like, all right, well, you want WebSphere queues? Sure. Like I've never heard of it, but sounds good. We'll just add it anyway. So yeah, people use MQTT and NATS and Kafka and RabbitMQ and GCP PubSub. There's ton of them, but really anything that is usable for transmitting a message and it being sent to somewhere else, that basically works as an event bus or a message bus.
Awesome. Thanks. And then going back to the discussion you guys were having about performance, I know that you've said several times that it is definitely faster to use like the event-driven system because you can write these events really quickly. But I assume that one of the downsides to that means that you don't you write an event, but you don't actually know if people have consumed it or done anything with it yet. So it's faster in the sense that you write things, but I assume you would have this like eventual consistency problem where you can't count on, things just happening in a certain order. Is that true?
Absolutely. And you just, man, that's a term that I just absolutely love. I think that eventual consistency in this case, you have to be okay and accept eventual consistency into your heart and say that this is okay and I am okay with it. At the core of it really is that you have really no guarantees. You can add guarantees into it if you want to and can have special acts and so on. But in general, if you just simply accept the fact that you know that it's eventually going to become consistent, it's okay and it's good enough. And I think that's a building block for the entire architecture. Basically, you are okay with things just working eventually. It's totally possible that things are going to go down and they will not be immediate, but that's okay because at some point in time later in the future, like let's say like when a service goes down, doesn't consume an event, it'll come back up and then it'll consume it and the system will become in a correct state again. Yeah. Got anything to add, Steve? I think that's.
Yeah, I mean these are all considered. I'm surprised you didn't say the I word, Dan. Would you like to say the I word?
Idempotency.
There you go. So yeah, I mean that's the crux of it, right? Like you're firing off a bunch of asynchronous events, and they're not guaranteed to be delivered at the same time. So you have to make sure that when you read these events, that a change that occurs in event A does not undo the change that occurred in event B, or it basically just it's a no-op at that point. So it's again, it's a design decision that you have to kind of incur, or a decision that you have to make. And once you kind of get used to doing that, the fear, uncertainty, and doubt around an event-driven system kind of goes down because now you have things like dead letter queues, you have things like event retries, that sort of thing, to kind of help mitigate these failures that do happen, and they happen all the time, even in managed architectures like, say, an AWS cloud environment. And these things always happen to everybody, so you do have to do things to mitigate that stuff.
Well, that's part of it is also right that I mean, just the concept of event-driven or like even event sourcing in this case is that you're able to replay the events. That's part of the reason why we're doing this in the first place, is that when there is an outage or something bad happens, you can basically take those events and shoot them right back, right? And basically ensure that the system is going to go back into the correct state. But it's what Steve said, like, yeah, I love to say the word idempotency, even though I don't know if that's the correct way to pronounce it. But anyway, so idempotency, it just needs to be, it's just a thing that you should build your services with from the get-go, and things are going to be okay after that.
So you brought up two things. One, the idempotency, essentially, and you were talking about replaying. So I assume that means that it's uncommon to rely on messages being delivered exactly once, or events being delivered exactly once. Is that pretty true?
Oh, yes. The snake oil that is exactly once delivery. So I believe, yeah, that once we've come up with a perpetual motion machine, then yeah, that exactly once delivery will also happen. It'll be great. But until that happens, I do not believe in it. I have never seen it properly be implemented ever. It is doable. I guess it's in some really, really closed circuits and like really controlled environments. But I mean, technically it's very hard to guarantee that if it relies on even electricity. So yeah, you should, for event-driven systems, you should not rely on exactly once delivery, even if it sounds plausible. You should just not, because at some point in time, someone is going to re-emit a message accidentally twice, and then basically you're in a world of hurt. So instead, just build your systems with idempotency in mind, that you will have there's a possibility that an event is going to get duplicated. If you want to do duplication on your side, go for it. But like the easiest one is that, like, have I handled this before? Yes, I have. Ignore and just move on. It's so much easier, the logic that's involved in that.
So when you talk about handling that, what are some techniques that work well for making things idempotent? Is it just like looking at an event ID of some sort and being like, oh, I've handled this one? Or is it something else? Like, are there other techniques that work well?
Timestamps are pretty sweet. I like timestamps a lot. Totally, you can like depend. It again, like in the words of Steve, it depends, but mostly it depends on how important the data set is, right? And I think so. You can absolutely look at timestamps and just basically say if this event has, if this event, if the event that I have already handled has a timestamp in the future, right? And then and another event that comes in afterwards has got an older timestamp, don't worry about the older event, just dismiss it. And similarly, every service here can have its own data store as well. So that means that, like, you can have your own caches and all kinds of stuff. So you can either build it, put it in memory, and then put basically keep a track of all the messages that you've already handled and so on. Keep that stuff either in a cold cache in etcd or in mem or wherever. What Steve was saying, what you were saying, sorry, like in regards to like keeping track of IDs and that sort of thing. You could do that, but it's generally speaking not really necessary, I don't think.
So it sounds like, generally speaking, with an event-driven system, do you just naturally get an event log or an audit log of some sort that shows you everything that have happened in your system, or is that something you have to build into it?
That is the awesome part. Well, you'll still need to build some sort of a archiver of sorts, but like in general, as an event, because the event is the source of truth, you're basically getting audit logging for free. That's essentially what it comes down to, that every single thing that has happened within your system, it's if folks are familiar with like concepts of like change data capture, that's essentially it, where you're plugging into, so actually, let's roll back. Change data capture. Change data capture is basically, plugging into a database's replication log, watching every single thing that changes. If you need like some sort of compliance, let's say like SOC 2 or something like that, you probably will need that sort of stuff, right? And you're going to need to set up some sort of a pipeline to actually read all those changes and so on and record them somewhere. With event-driven, it's the same exact thing, except there is no database. You have just a message bus. So you would basically record every single one of those events. And those events are essentially your change data capture. You're watching everything that has happened within your system, right? So you do not need to build yet another system to say like, oh, now we're going to have audit logging, that sort of thing. So it absolutely is an audit log. With that said, you will need to build some things on your own. That's part of the reason why we built batch as well, is because we didn't want folks to have to build all this stuff on their own or whatever on the side. So it's a decent sized endeavor, but you totally get a lot of free functionality out of it as well.
I would imagine, at least in my mind, that some of the added functionality also comes down to just like making things like seeding a developer database or things like that sound like they'd be a lot easier if really that process is just having a set of events and then sort of running them, and it doesn't, you don't have to worry too much about how your system has changed over time or anything. Those events should still theoretically replay and get you to the right place. So is this something that ends up improving the developer experience, when we're not in production and we're working locally, or how does that affect the developer experience, building something?
Want me to take it, Steve, or you take it?
Yeah, I'll add my 2 cents. So to me, the ability to replay events, even though events are supposed to be delivered asynchronously, the same batch, no pun intended, of events being delivered in a let's say a test is really helpful, particularly around testing the boundaries of connected services that are connected via event propagation. When I'm able to, and I'm saying this as a consumer of batch.sh, when I'm able to replay a batch of events that I've emitted to the service, in let's say an integration test, or even a unit test for that matter, it just reduces the amount of work I have to do. So for me, the biggest positive of replay is, other than auditing, it would definitely be for just testing with known inputs. Consistency.
I think it's totally. There's a really big piece of event-driven. So I mentioned the word event sourcing, and it's just basically a sub-architecture of event-driven. And it's actually, let me just quickly spell it out. So basically, in event sourcing, the idea is that you're able to utilize the events to essentially build another data source. Because we are considering the events the source of truth, it basically enables a developer to essentially spin up their own data store utilizing the events, right? But the data store only is pertinent to the service that they're building. So that is incredible. So where in the past you would basically, let's talk about like a regular architecture, you would probably try to find a dump of, try to create a dump of the previous, like some main monolithic database, import it into your own DB, and then build the feature off of that. And now you have a second problem, which is like, well, now my service is either connected to this other DB or I have to keep them somehow in sync. That stuff is gone because you are essentially plugging into all the events, like the ones that you're interested in. Say you filter out and say, like, you know what, I know that there's like 5 billion events in there, but I only care about the billing events because I'm the billing service. Well, you basically siphon off only the billing events, build up your own data store with just the events and how, what they actually represent, and build the DB as to how your service would be best to utilize it, right? Like how your service can best utilize it. So
I'm glad you answered that one, because when I was writing the tweets, I didn't quite realize the difference between the two. So I wrote one that had event sourcing, and Chris actually pointed that out to me. He's like, "Are we talking about event sourcing today, or just event driven?" So does that answer your question, Chris, or do you have more?
No, I think that answers my question. I think the other thing that's important there too is that there's a distinction between the two a little bit, of event sourcing and event driven. Like, you don't have to do event sourcing to do event driven. And you don't necessarily have to do event driven if you do event sourcing. It can be useful on its own. But it's important to not conflate the two, or you'll wind up in a really awkward world, I think, most of the time.
Totally. Yeah, we probably should have started off with that, like to because they are extremely similar, and they work with each other as well. And there's quite a few like these sub architectures. There's like CQRS as well. There's like Saga patterns that you can utilize, and they all kind of work together. I just look at it as really event driven is the big one. That is like an umbrella term that basically encompasses all this other stuff. And there's like different ways how you can, utilize it basically. And one of them is like event sourcing.
So you both mentioned, replaying. You can technically replay events, especially if you just want to like seed a database or do some testing. in my mind, this seems like something that would make a lot of testing simpler, because rather than like having to spin 6 different services up and make sure they interact correctly, you can sort of just, it's almost like a unit test where it's like, here's the input. Does it emit the event I want it to emit? Is that generally what testing ends up looking like?
Totally. It's
Yeah.
actually, here's some anecdote time really quick. And it was awesome. It was the first time I ever experienced this like in my entire career, where basically when we were building our company and we were building out the architecture for it, we didn't actually have a database behind it for the first 6 months, I believe. Everything was so event driven, you'd say, that all we did is basically just write features, emitted events, had another service consume the event, and then we moved on. And because you're utilizing some sort of caching, because you still need to bootstrap your services, right? Like, and you need to keep some sort of state within the service. So we would use etcd behind the scenes, and we would basically, as we consume an event, and we want to say that like, oh yeah, this event has been consumed, or we've done something with this customer, save it to etcd. Service starts back up, loads it from etcd, and we're back into the same thing. So in that particular case, then, so a database and these concepts of having to see the DB and so on, they're all basically gone. You don't really need to do that sort of stuff. So in regards to testing things, or whether it's like actually part of your CI and so on, yes, you're essentially just emitting events. You rarely will have to like do some sort of DB mocks and so on to actually perform your unit tests or integration tests.
I feel like this is obviously all great, but one of the things that's kind of always in my mind when it comes to event-driven stuff is, how do you manage A, designing the events well, and then B, kind of updating or changing those events when you like need to add something? Is it just, I guess, what would be your suggestions to people that are getting started off with this? Because there's a number of different paths. You can add things to events. You can make entirely new events. I don't know, like what are your thoughts on that topic?
Oh, my favorite topic. Almost my favorite topic. I don't think it's an unpopular opinion, but I am 100% in the camp of you should use protobuf. You should not use anything else. You should just use protobuf and just call it a day and follow the best guidelines for how to write protobuf schemas. Protobuf is not just for gRPC. It's great for gRPC, but really you can use it as a message envelope as well. And all the same patterns that apply to writing good types and so on, and how to deprecate them and so on for like when you're writing a gRPC service, all the same stuff applies still. Same with, however your CI pipeline is set up to actually compile your protos. Same exact thing applies to these schemas as well. You use proper tagging, you vendor them in your code or whatever. Basically all the same good practices that you would usually do for gRPC, you do the same thing for protobuf. I would just say avoid JSON. That's like, if you do not want to have conflicts, that is how you avoid them. Having something that's strict, and I think Steve touched on this like briefly in the beginning, that basically having something that has a strict schema is the friend here, so that nobody can just go out of their way and just willy-nilly add various, some field or change a type of something and so on. If it is stamped down, such as with protobuf, then it will make everyone's life significantly easier.
Yeah, the protobuf compiler is, just to illustrate what Daniel just said, like gRPC is just one of so many uses for protobuf, especially the compiler. Granted, some of the Go code that the protobuf compiler generates is pretty ugly, but it's also highly performant, and it's also just really easy to work with, although it's a bit verbose. But you can write plugins for protobuf compiler. You can do basically anything based off a common a common dialect of your abstract syntax tree, where you can kind of go in there and assign properties, create functions, that sort of thing. I mean, it's kind of just a toolkit that you can use to do anything with. And the reason I like using protobuf is because it works across several, stacks and languages and that sort of thing. So if on the back end we're writing Go code, on the front end we're writing, TypeScript, we can share the same definitions, and we don't even necessarily have to share the same entirety of the definition, but just a sub slice. So you don't want to expose data to the front end. All right, write that into the compiler rules, right? You can just, expose just enough that the front end experience does what it needs to do, but you're still working off the same data definition, the same schema. So when you update the schema and then do all the code gen, then, as long as you're kind of like using proper semver and all that stuff, you're going to get that to propagate across all your services, including, clients and that sort of thing. And it's just really, I don't want to say it's magical, because it certainly isn't, but it's kind of magical. So
I want to add a quick shout out, by the way, to IntelliJ up in here, okay? Because the IntelliJ Protobuf plugin is so great. It works so well. And that is a massive part of the reason why I absolutely love Protobuf for this, because it is just, it does so much for you, like in regards to even like includes of other protos. So like the schemas that we utilize at my company are fairly complex. There's I mean, tons and tons of different types, and they're included back and forth between different places. And yeah, as long as your editor is able to support that stuff, it is super awesome. And I would say that's the one thing that you're totally going to miss with JSON, like almost guaranteed. You're not going to be able to construct really complex schemas, that are representative of what you actually need. You're probably going to cut some corners, and then you're going to get bit when you forgot to add a comma somewhere. So.
I feel like this is also a good use case where you could bring in one of the other a topic we've had a couple weeks ago of using Q, and kind of bringing Q and protobufs together to help give you some of that, constraints that you were talking about, Steve, around like what is valid in a protocol buffer. Because I've definitely found that protobufs is a great universal format, but it's missing some of that like constraint or required fields or anything like that. And there's good reasons why those things are in there, but at some level you need to express those sorts of things.
I'm a really big fan of Q. You're referring to QLang, right? Like I'm a huge fan of QLang. Unfortunately, I just really never had the use case to switch over to it. But I just, every time I look at the docs, I'm like, this is just a really nice way to kind of build out rules without having to actually code them. Yeah, it's pretty awesome.
So if we're using something like protobuf or QLang or anything like that, really, as far as I can tell, it's mostly language agnostic. Are there any benefits to using, like, does Go bring any benefits to using it in an event-driven system over some other language?
I'll start with this because I'm sure we've both got opinions here. So I think the primary benefit for me is that I like are all the concurrency primitives that are in Go. In event-driven stuff, you tend to have to accept an event, read something, fire off some one-off jobs to do something specific, in the service and so on. And being able to spin up a Go routine that is cheap and not having to think about threading or how it affects your instance or whatever is pretty awesome. From the simple concept of, right, like you're not going to be able to launch 1,000 threads on, or difficult. It's going to be very difficult to launch 1,000 threads in Java and expect that everything's going to work great. Whereas in Go, you really don't even think about the concept that, like, oh man, I'm going to have to spin up 500 of these. So that is super awesome. And from the perspective of protobuf, Go, the fact that, protobuf, the syntax itself is so similar to Go, and the type system works still the same way as well. Even the dreaded like false / whatever the default false is there. There's very little surprises in any of it. It works very similarly between how you would write Go and how you would actually write the schemas themselves. So and the tool set itself just works extremely well with Golang. So Yeah, I think it's a fantastic package for it. And the fact that, I mean, Go is so incredibly simple to get bootstrapped into, to like, I mean, start developing in this language. It is fantastic for building tiny services quickly, regardless of the architecture, whether it's like event driven or whatever else. It doesn't take very much. One last part is also the quality of the libraries. That's a really big deal. The quality of the libraries in Go for event bus, like for message buses, is really great. Like the quality is quite high. We have, as a result of working on this tool called Plumber, we basically have had to interface with pretty much every event bus under the sun. And it is written in Go, and we use basically the library that has most of the stars, and they always work really, really well, even in production as well. So, and just a quick side note then, for Kafka, there's the segment library, and it works fantastic. It is absolutely an excellent library. And the same way for all the other main message buses, it's the ones which are fairly popular are the ones that work really well. That's basically it. So.
Yeah, just to add on to that, like what makes Go, I think, a really good language for an event-driven system, just to echo what Daniel just said, is the concurrency primitives in the language itself. It, for me, and others may feel this way, others may not, but for me, it's really easy to transition my thinking from the event bus to the language, because I can think in Go routines, if that even makes any sense. Like I can think about, I can reason about the events being accepted into the system a lot easier than if I were to have to create a thread and then manage its life cycle. Whereas in a Go routine, I mean, you have to know how your Go routines end, obviously, but it's a lot easier. It's just a lot easier and a lot less cognitive overhead to worry about. So for me, at least, that's one of the big, because I only have so much space available up here, and the less I have to think about managing threads, the better.
So a follow-up question then, I guess. A lot of our listeners tend to be people who are learning Go, or who are sometimes new to programming, or maybe they're even expert developers, but they just haven't touched something like this. So what would you recommend? Like, do you have any recommendations you give to people if they want to build like a starter project using event-driven? Because I'm guessing they probably don't want to go build a production system first shot, maybe, but it seems scary.
All right, I'm going to give it a shot. So, I'm gonna put some opinions here. This is definitely opinion time. This is not the definitive way to do this, but throughout my career, I have basically come to a preferred setup for this sort of stuff. I will talk about the production side of things first, just to keep that out there. But basically, I think a production setup would consist of Kafka, and that would be utilized for high throughput messaging. And I would utilize something else, like let's say RabbitMQ, for facilitating actual inter-service communication, right? Like inter-service communication. So, and the reason being is that Kafka is incredibly fast, but it's kind of a beast. And to try to set it up and to even write a consumer and a producer in Go for it might be complicated. And also on top of it, it doesn't have a whole lot of routing capabilities. Like you cannot say that I want this type of message, but I don't want this type of message, or based on headers, or based on the routing key that is being used for writing the stuff. So I would choose Rabbit for that sort of stuff. For somebody who's starting right out, basically just Rabbit and protobuf. That's essentially all you would need to be able to start building this sort of a system out. I would take care, though, to learn about all the different capabilities that Rabbit actually has in regards to the sort of like complex routing mechanisms you can come up with, because it will 100% influence your architecture, your software architecture itself. There is a lot of stuff that I have even learned several years after like running Rabbit in production and realizing that oh my God, I could have done it this way, and that would have saved on so much complexity, like maybe like some sort of a delivery pattern where it only reaches one specific service under some specific, conditions or whatever. Yeah, and then another piece, I think I mentioned it throughout a little bit earlier, is etcd. I am a massive fan of it because you could use for a cold cache, obviously you could use something like Redis, but the idea is that you want to utilize components that are scalable, right? That hopefully are distributed and hopefully can horizontally scale. etcd is one of them. It can totally scale horizontally. And it's extremely resilient to latency issues as well. So it makes, I think, especially now that it also has gRPC transports as well inside of it, it makes a fantastic use case for just using it as a caching layer as well. So maybe somebody who's starting out doesn't need a caching layer, but if you're doing something production level, then I would say it makes sense. So
I would say, and this is probably not even though we're not on that segment yet, not a very popular opinion, but I would advise people learning event propagation specifically to not rely so much on all the stuff that a library gives you, let's say, but just focus on the wire protocol. Like think about how things look going over the wire, which is why etcd is actually really, etcd is super lightweight. Like etcd is fast, it's lightweight, it's very simple. So MQTT is the same way. They're very easy, and they're very easy to understand, because I think you need to understand exactly how messages are communicated across the wire. I mean, you don't necessarily need to know that in order to write the system, but you should understand how they're propagated, what the actual protocol looks like, and then you can kind of step back into bigger and bigger realms of functionality. But I really truly believe that starting out, you should try to just stay as close to the metal as possible, and even if it's a toy implementation. I mean, that's how I learn. So I think others may be the same way. I know some people just like to use the tools, but I guess I'm the guy
I think
that
that's
tore
a great
apart.
point.
Yeah.
Yeah, because like MQTT is incredibly simple. There's really nothing to it. So yeah, I would agree with that totally. Start out with just actually understanding the simple transaction of I emitted a message and somebody else consumed the message. And then from there on, you can go on further or whatever. So my point about Rabbit really is just the fact that I've been in that boat before where I have written something and they utilized Rabbit for something, and I had to architect around the problem and come up with a crazy design, only to later find out that like, oh, it supports this fantastic feature, and I could have routed messages in this manner, and I wouldn't have needed all this like crazy complexity around it. So that's just a general word of caution that like that sort of stuff needs to be figured out. Like there's not a whole lot you need to learn about MQTT. You put a message in, you take it out. Like that's what you need to learn about it, really.
That's it.
And then, but if you use like more complex message buses like Rabbit, then you should probably look into it, because there's all kinds of different paradigms. So.
All right, we are getting near the end of our time, so we're going to move to unpopular opinions. But before we do that, is there anything you two would like to add about event-driven systems or anything else that we're missing?
I'll just go first. Yeah. So
if you guys are ready for
yeah.
unpopular opinions, then Daniel, what is your unpopular opinion? Normally there'd be some like intro music here, so.
Yeah. So I guess it's probably unpopular. I think so, at least. But I am super against continuous deployment. I cannot stand the concept of it, and I've seen it break so many different things at the worst possible times as well. So I am a huge proponent instead of owning your deployments and like owning your deploys and considering marking a ticket as done. Truly, when it is actually done means it is deployed into production, and it shouldn't be thrown over the wall. It should be your responsibility to actually deploy this thing. So yeah, gone to great lengths to institute that at various different organizations and then be generally hated, but that's okay.
So if I'm understanding this correctly, you're okay with continuous integration for testing and that sort of stuff. You just don't like the deployment aspect.
Yeah, totally. That's exactly it. Like, I think that absolutely there needs to be CI. Like, and your CI pipeline can also build, should actually build the artifacts and so on as well for additional testing or whatever. But ultimately, when you click that merge button in GitHub, it can totally kick off something like some sort of CI that's also now going to build the artifact and push it to, like, I don't know, Docker Hub or whatever, or some GitHub registry. But the deployment part itself should be actually manual to some degree, right? And I'm not talking about 15 steps with a run book or whatever, how to deploy stuff. It should still be a make deploy, make deploy dev or something like that. But that should ultimately just be essentially a Kubernetes deployment, right? Like, you're just like kubectl deploying you're deploying YAML basically. So, which is pointing to the latest, Docker image or something like that.
I don't really have a strong opinion one way or the other here, so I can't really.
I think the big piece here is that the reason why, or the thing that I've seen in the past throughout my career is that basically it has been the deployment part has been basically treated like the SRE/DevOps part, which is or a QA type of thing, where it's like, well, we created this functionality, throw it over the wall to QA, and QA is going to figure it out and see what's happening, throw it back over the wall. Then the devs are going to say, oh, that's not totally right. Throw it back over the wall to QA. Same exact thing here. You own the thing, you built it, you know how it works, you know how it should be interacting and how it should respond and so on. And you are the best person to see it to its conclusion, essentially. I don't know if this is an unpopular opinion as well, but basically, if it's in master or in main or whatever, then that is what should be deployed, right? That is what should be actually running in dev and in production. So.
I forget what project it was, but I've actually seen, taking what you just said there about master being what should be running in production. I've seen some app, a couple open source code bases that take the weirder approach of master doesn't necessarily always compile, and basically if it's not a versioned release, it's not really expected to, and that one always threw me off. Because I'm kind of in the same mindset of you is master should be something that anybody could grab and it should work and we should be good to go.
Yes.
But
100%, it should work. Nobody should be expected to go into tags and start looking for let me find I know how your project works. It probably uses the stable tag, right? And then God forbid they use the incorrect tag, which is actually minor numbers means unstable. No, I don't need to figure any of that stuff out. I just want to go grab master and make it work. So, anyway.
Part of that's also built into the Go community since for so long, master is what Go Git would get. So if master doesn't work, then no one's going to use your library because it's broken all the time.
Yep.
And maybe that wasn't such a bad thing. Maybe that was actually a really good thing for us as a community. It taught us some good skills.
It's
agreed. Yeah.
I will definitely say that Git branching and how people decide to do that is something that I don't know if I've ever quite been at companies that all do it exactly the same. Now, granted, I haven't been to a ton of different companies and I've worked for myself a lot more, but I've definitely seen different companies all do it differently. So it's sometimes interesting to see the reasoning behind it. But yeah, as far as continuous deployment goes, I have no strong opinions one way or the other. I feel like in most of my projects, a huge chunk of my career has been on very, very small teams where you're pretty much responsible for everything regardless. So I completely relate with that. And I haven't really had a lot of experience on the other side where you have the opportunity to throw it over the wall. Maybe if I had the chance, I'd love to try it because it would mean I could
totally. That's exactly what happens. It gets thrown over the wall. And I mean, usually there is going to be a dev that still sees that it shipped or whatever, but something is going to break at the most inopportune time at 2 a.m. on a Thursday. And it's going to be some SRE dealing with this thing and not realizing that, that this particular dev is responsible for it, right? Because like they didn't test that particular edge case, or that sort of a thing. So yeah, this is just, it's an ownership thing. And I think that also we've gotten very used to the concept now of automating everything, because automating something even, I don't know, 6 or 7 years ago, you needed to have a decent skill set, right, to like be able to automate stuff in the first place. You needed to be a programmer of some sorts and be able to do that sort of stuff. And now I think every SRE is expected to be able to write code, essentially, right? So we have this ability now to say like, well, everything can be automated everywhere. And I guess what I'm saying is that not everything should be automated.
This reminds me of, I swear I read an article about GitHub, how they use some sort of bot or something where basically developers would pretty much deploy a branch to production, verify things worked, and then that's when it would get merged into master, I think. But I remember reading some article about their deploy process, because it was like, on one hand, it looked rather chaotic, because I'm like, they have a lot of engineers, and if they're all deploying things and verifying they work, that sounds slightly scary. But at the same time, the ownership aspect of it, I definitely agree with, is, having somebody actually verify their stuff when they deploy it.
Okay. I think it's I was just going to say that, like, I think ownership, that's a fantastic word for it. It is proper production level service ownership. That's really what it's about, right? Like, you're owning the service from the beginning to the end. You're owning its dependencies. You're owning everything for it, right? Including even its CI process, and it's like, if it has a CD process, you should own that too. You're owning everything. So please continue. Just needed to add that.
All right, Steve, do you have an unpopular opinion you'd like to share?
Yeah, I shared this with Dan yesterday, and he didn't like it at all. So I'm pretty sure this is unpopular. I think the overuse of ERR as an error variable, I think it makes code harder to read. I really do. Now, there's a lot of guardrails around that statement. I mean, obviously, you shouldn't be writing 200, 300 line functions. But I don't know. I think the error should in some way describe what the error actually is, even if you put like a M or a G in front of it. I don't know. I see the reuse of too much, and it makes, I don't know. To me, it just makes code a little harder to read. As a corollary to that, I think there's another part of the language that people don't use enough, and that is naked braces. You just have two mustache braces, and then to me, like, I look at the code and I can just totally read it a lot cleaner, even though it does some things with scope as well. It just makes things a lot easier to read. So, an old guy like me with failing eyes, it's really hard for me to kind of figure out where that error began. I just can't. So just give it a better name. That's my opinion.
I will definitely say that the error variable is one of those things where I feel like as I've had more experience with it, it'd be weird not seeing that as the variable name. Not saying it would necessarily be worse, but it just would throw me off at first because I'm just so used to seeing that. And I definitely get that throughout the life cycle of a program, like, it's kind of hard to, like, basically that's the one that gets reused, like, by far the most throughout a program. So I get that aspect of it. I don't know. I'd almost have to see an alternative approach before I could even, like, give any sort of feedback, I think. And like you mentioning the naked braces is, to me, I've never found a use for them that I liked. So I'd love to see how you use them sometime. Like, what
I mostly use them in tests, actually. Like,
okay.
If I want to, I create kind of like this, this reference variable at the top, and then I just I can do a lot of copy paste in a test and not have to worry about redeclaring or the compiler yelling at me for redeclaring a variable. So it's more out of laziness, but it also makes it easier to read. Like, it's almost like a stanza in a poem. You can very clearly understand, okay, this is a very specific block of functionality versus, just several lines of
I forgot that functionality even exists.
It doesn't.
I've been
get
doing
used very
Go for
often.
like 7 years. I didn't even think that, like, I literally am getting like pings of like reading somewhere whether this is a thing. And now I know there is somebody that they added this feature for you, Steve.
Just
Perfect.
for me. just for me.
I've heard people talk about it in the past, and every time I've like never really seen a good concrete example of it. So maybe I'll have to bug you later and ask for an example, Steve, that we can share with our audience, because
Yeah, absolutely.
it's definitely something I'd love to see more examples of, because I've seen enough people mention it that I'm curious how it's helping them. But I for whatever reason, my brain just hasn't quite made that mental leap to figure out where I might use it.
I think on the error thing as well, I I like reusing error. Like I don't like having to come up with like new names for errors, but I also feel like it like errors have become a sort of half fulfilled promise in Go, because Rob Pike was really big on like errors are values. They are not something different. They're not something separate. That is why we don't have exceptions or like this separate class of way of handling errors. They're values. You should treat them as values. And we as a community just never really followed all the way through with that. We're like, okay, yeah, they're like their values, they're like in there, but we don't treat them like all of the other values. We still have this like,
Yeah.
it's a special value. And I think that allows us to have this laziness around naming it, because it's just like, oh, it's a special thing. It's fine if you just always call it you don't have to call it something else. But we wouldn't do that with other types of values in Go, because it would wind up making our code harder to read. So I think I like half agree with you, even though I'm like, I don't see the problem with errors. I can see how that is a sort of annoying thing and like an inconsistency in the code that we wind up writing.
Oh, and I admittedly, I mean, if I'm in a code base where that's being done, I just go with the flow. So I don't, well, most of the time I just go with the flow, because I don't want to be the one to push my preferences on other people, even though it does take me another hot second to figure out where that error started. So another, interestingly enough, context is the opposite. Like to me, context, CTX, everybody uses CTX for context. To me, you should never use anything else, because just by the design of context, it's just one wrapped context after another. So if you're creating a logger context or a trace context, that kind of thing, just keep it, because then it'll just propagate through your code. You don't have to worry about, oh, is this a child context that doesn't belong to its parent, to this parent over here, kind of thing. So I don't know. The difference to me is kind of night and day versus errors.
Like context is something where I feel like there's only one, and you generally only get it from one place. It's not like you're getting context from two different sources and like dealing with, I've at least never seen code where you get two contexts and somehow have to manage both of them. Whereas like the error does technically come from multiple different places.
Yeah.
And Chris, when you were talking about like naming them as variables, the one thing that popped in my head is I wonder if you would even be able to get code accepted that doesn't have ERR in it somewhere, even if it was like, like thing error or something, sort of describing what the error was. Like people would probably be fine with that. But if you just like named it something else, I don't know if people would let that fly. Whereas like if you have a map of people, it's not like people map. It's you just call it people or something. So like that's kind of the weird, like it is a special case where people don't want to not have the word error in it, even if they're willing to just not use error.
Yeah. Some of these idioms are just totally organic. Like that's one of them, that just, it's what everybody does. And
it's a weird dichotomy too, because as a group, I've noticed that most software engineers don't actually like dealing with conflict and error handling. It's just like people would just rather ignore it. So they're like, oh, I'm just gonna like relegate it over here, but I'm gonna be mad if you like kind of build it into the actual flow of everything. As if like if errors weren't there, people would be like, where's all the problems that go wrong? And it's like, well, there's a lot of different classes of ways that things can go wrong, and you can define different ways of expressing that. It doesn't have to be an error. So despite people like not wanting to deal with errors most of the time, they're very set on like having the errors be very visible so they can very visibly ignore them. If you just kind of build them in other ways, they get very mad.
I'm even thinking about like, if you know that your function only returns like one specific type of error that's more concrete than the built-in error, I still don't know if I've ever really seen functions that return that instead of just returning the built-in error as the type, when in reality returning a more specific error type would actually be way more useful, but we don't ever do that.
Yeah, and then you get into the business of like doing a type switch on the error itself, and then that's a code smell to me too. Like, I mean, sometimes you kind of have to do that, but it kind of defeats the purpose.
That's a great idea. That's exactly what I like
Like,
to do.
In
Type
general,
switches
to
on
me,
errors.
yeah. In general, to me, unwrapping an interface into a concrete type is a code smell, pretty much across the board. That again, that may be an unpopular opinion too. That's kind of
You've got me curious now, though, if I went through a code base and actually factored it to be like, I'm going to return the most specific error type I can in every case. Like if I have like an interface that defines a more specific error or something, and just to see how that would end up. I do imagine one of the issues would be that you couldn't reuse that error variable all the time because you'd have different types being returned. And that's probably one of the reasons why people dislike it, is because they want to keep reusing that error variable.
yeah.
I think that listen, friends, okay, we're in the friend circle here. Okay. There is not found as an error is a typical error that adheres to everything, right? Like it's basically the equivalent of a 404. There is no reason why there couldn't be like an error that is called not found error. And you could just return that and call it a day, and that's it. And it's always there. And thus you do not have to do, if error string contains this and this, and it's not found, then it's a not found case. Because sometimes you do have to see what kind of an error it is, right? So I'm just saying, you don't necessarily have to do switches maybe, but you could probably be able to do an if, on something just to emit like a log line or something.
Oh yeah. Errors.is my best friend. I use it all the time. Errors.is and errors.as, they are, fundamental part of my workflow now. So to take those away from me would be terrible.
Yeah, it definitely seems like this is an area where it'd be nice if we could advance in some way away from. It feels like a lot of our error handling and errors end up being simplistic, like stuff people think about after the fact. Because it's like, yeah, your errors should be rich. They should give you lots of information about like what went wrong, so you can like handle the cases or retry or do whatever you need to do. And most of the time, it is just like, here is an opaque string that you can go parse, and maybe I've implemented something internally, but I just expose that out as a bunch of opaque strings. And if I change those strings, then you're kind of screwed. But once again, takes a lot of energy to think about, your error flows and your error cases. And
yeah, I get a lot of flack for this, but I love bit masks. I love using bit masks for that purpose, because you can stuff in a 64-bit unsigned integer, you can stuff 64 error cases into it, and it could be any of these or all of them, and you could just check it using a bitwise operator at the end, and it's very fast, it's very efficient, and it's readable. So. But for whatever reason, bitmasks aren't as popular as they should be.
I believe I've created or have worked with some sort of a higher level error library. Like pretty much at every place, there's somebody that comes in as an afterthought and creates a higher level error lib, right? That's what Chris was talking about. That like you would want to have like all kinds of stuff indicating where did it come from, some sort of statuses, how you should react. Is it fatal? Is it not fatal? All that sort of stuff. And it almost always sucks. Like something is busted with it. Like either it doesn't log at the right time when you want it to, or it logs too much, or it does double logs, or it doesn't send a span or a trace somewhere where how you need it to. It's just, I'm down to complain about it. I don't have a solution. I just want to complain about it and say it's not great, but like, and I wish it was better, but I don't know how.
Yeah, for whatever.
Oh, go ahead.
I was going to say, for whatever reason, it just seems like an area that's it's hard as a developer to justify spending too much time there. Like, because you're getting paid to make things work. And it sometimes doesn't feel like you're getting paid to like make handling the errors easier. And for whatever reason, like the way error is, I mean, like, yes, you have to handle the errors, but for whatever reason, like, I don't know, upper management cares about the working thing. They don't really put as much thought into did you also handle all these error cases? Until something goes wrong, then they care. But prior to then, they don't care so much.
I think that's like an ethos thing that we probably need to fix at some point. And like, I don't know, I always kind of relate it back to, my history as a writer. And I'm like, nobody likes a story where there's no conflict and nothing goes wrong. So the fact we build our software and people want us to build our software in this realm of like, don't really think about the errors or the conflicts or the problems. Things will mostly work all the time. It'll be okay. Is kind of it's weird to me because like the important stuff in like a movie you go watch or a book you read is all of that conflict and the errors and how you resolve them. And I think properly handling that is what makes a difference between like really great software and like mediocre software. And right now people are okay with building a lot of mediocre software, but I think users are getting increasingly annoyed at that, because a lot of those like turn it off, turn it on again bugs are because someone didn't handle some error case somewhere or didn't understand the semantics properly. Now everything's busted and no one knows where the problem is, so we just restart the whole world.
Yeah,
I will not approve. I was just going to say that I will not approve a PR which doesn't check the error for a JSON Marshall. Okay, like you should check all errors. It doesn't matter. I understand that I understand that the only error case for a JSON Marshall is that if it's like an infinite math number or something like that. I get it, but I do not know what's going to happen in the next version of Go. And like Rob decides that, like, actually, you know what? If the host name contains squirrels, I'm going to actually error. So check all the errors. Check everything. That was a convoluted, error case, but like, you get what I'm saying.
I feel you. Another thing. Sorry, John.
Go ahead, Steve.
Yeah, another thing that is in code bases that I've seen is generally inconsistent, depending on who wrote the code, is how errors are actually propagated. In a typical RESTful service, you have this entry point. You dig down into the service layer, into your data layer, and you may hit an error. Some people like to log that error right where it happens. Some people like to propagate it the whole way back up the stack. It's one of those things where you have to pick one and stick with it, because if you don't, then your observability is going to be terrible. Everything is going to suck. you got
and your price is going to skyrocket for your logging platform as well, right? So
I like thinking about the error stuff and just how hard it is to handle them well. Like Chris, you were saying that like how you resolve conflict is a big part of what differentiates great and mediocre software. And one of the first things that comes to mind is like when you're submitting a form, and some forms will come back and like literally tell you every little thing that's wrong. It's really easy to sort of figure out why your form didn't go through. Other ones you get like a generic like this didn't work message, and you're like, well, that sucks. But like weirdly enough, we've set things up so that it's much easier to do the first than the second. Like it's much easier to have the generic something's wrong than to actually show somebody like here are the things that went wrong. Because I even went and did that at one point. I sat down and I was like, all right, I want this form to like literally highlight every field that goes wrong, and the errors are coming back from a Go server, and like trying to figure out the right way to do that was not the easiest thing in the world.
Yeah.
But I feel like sometimes people just try to like sweep that under like the security rug. Like it's a security vulnerability if you tell people what went wrong. It's like, have you thought this through though? Have you really thought this through? Because I don't think you have. It's
like the same times that people will say when you go to the password reset and it can't tell you if that email address actually exists in the accounts. And they're like, oh, it's a security thing. And I'm like, I can go sign up with that email address and it'll tell me if it's there or not. So like, I can figure this out already. You're not helping anybody. So just tell me. And like those ones just seem like the same type of thing where they're worried about a security thing that is completely vulnerable in some other way. So it just does not matter.
People like to do selective security thinking. When it's like, if it's convenient for me, then I'll say that it's a security problem. But if it's like something I'll have to go think about some more or go fix, then I don't know. Then we don't really need to care about that security case.
The password reset forms just frustrate me when they're like, if you have an account, we sent you an email. And I'm like, that is not helping me at all right now. Like, basically told me nothing.
I literally just went through that flow that you were just describing just a few days ago of trying to reset a password somewhere. And I didn't know actually if I had an account there or not. And I went through that whole thing because I don't know if it's like, was there a mail server problem somewhere? So I went and signed up with an account and I was like, nope. Like definitely not no account here. So just, created a brand new account. So yeah, I agree 100%.
All right. I think that's about a wrap for this episode. Daniel, Steve, thank you for joining us. Chris, it was nice to talk with you as well. Thank you for joining.
Of course.
Tune in next week to hear some more about Go Time. And then we get some cool outro music.
Do.
Sometimes I have it, but I've been really lazy lately with that. It's easier if I'm not hosting, because then I can just sort of sit to the side and you play it when I need to and get things ready. But for whatever reason, when I'm trying to have a conversation and think about what you guys are saying and trying to cue up some music, it's a little bit trickier. If you guys haven't already, you can stop your recordings.
Sweet.
There should be a link, I think, in the guest thing. If not, over in the chat for Zoom, you'll probably have to copy paste it, but that's like a short link for it. So basically just upload your audio there. I don't think there's anything else. Did you both get emails sort of about like when you were added to the episode? Steve, you might not have because you already had an account.
No, I did not. I don't know
Okay.
when I even created that change log account.
I have no idea. I have no idea. I don't think I have access to actually see when you would have created it. I'll try to make sure you get one. I think usually they try to give you both t-shirts, Go Times t-shirts as well.
Nice.
So
Sweet.
that should be something you'll get a link for. They might send that
Guys,
out
this
whenever your
was
episode's
awesome,
published.
by the way.
Yeah, this is fun.
Guys, this is great. And I think talking about this sort of a subject was, I think that's the first time I've talked about it like out loud about event-driven stuff. So it's pretty cool. It was fun. Really neat.
No, it was nice to learn more. It's something I've heard cursory knowledge about, but I've never had the opportunity or the reason to dive into it more. So it's really cool to learn more about.
I think that's the thing. We mentioned it like earlier on the call as well, but like it's totally a thing of necessity, right? Like you really only usually get exposed to it through necessity, where you realize that I need to be able to handle, I don't know, 500,000 concurrent sessions or something like that. And you start going with like, well, I'm going to need to do this. I'm going to need to do this. And then you inevitably end up going into this space and starts thinking like, well, I guess I'm going to have to do more asynchronous stuff. And then you get the badge, the event-driven badge. Maybe you didn't want the badge, but now you have it.
You're stuck with it.
Yeah, you're stuck with this badge.
I worked on an XMPP server for a number of years, so my brain over that time shifted to like message-driven sort of things and event-driven. So every time I go somewhere, I'm like, why are we not using more event-driven things? Like, why do I have like all of these REST API calls and now I have to build in circuit breaking and all this other crap for that I could just have a queue handle for me and I don't have to write that over and over again.
Thank you, Chris. But everybody looks at you as a crazy man, okay? Like that's the thing. You're the crazy guy who is like talking about this super complex thing, but you're totally right. And I don't know if I mentioned it or not, but like Hystrix is like circuit breakers and like Hystrix style circuit breakers. I will take event-driven any day over having to configure a perfectly working Hystrix circuit breaker. It is, I've seen circuit breakers take down systems like more often than I've seen event-driven problem. Because like people do not know how to configure them. I cannot configure them correctly either. Like I think that I have it mostly correct, and then some weird edge case comes up, and you have to do something with it. So, or have to reconfigure it basically. So.
But I think there's like, so I've been thinking about this a lot. So I'm like thinking about trying to build like a very kind of like a platform like event-driven sort of thing. So I've been thinking about like because basically what I want to do is I want to use Kafka to kind of feed into other types of caches. So it's like, oh, you have your main source, and then I have like these different views on my data. And one of the things I was thinking about was like, man, how do I get like the data out of the primary database and like into Kafka in like a consistent manner so I don't have like, I don't like have something in the main database but not have it in Kafka. And it's like there's some really cool stuff with like Postgres and their change data system where you can just like pull off the REPL and then like pull off the replication log and then just dump it into Kafka, which I think is really cool. And then if you like add event sourcing with that everything becomes so much easier.
Yeah.
You should check out, by the way, this. Oh, I was just going to mention that like for the CDC stuff, this is not really a plug because like the tool, I mentioned Plumber before. If you're doing something like that, because like we just added CDC stuff to it as well. And you can just basically run it as a Docker container that it plugs into your Postgres wall log and it dumps everything into Kafka for you. You can totally use it for that. It's basically what it's meant for as well. But exactly for that use case, like that's why people actually even wanted this stuff, is because they do not have event-driven anything, but they just have a database, and they're like, well, it would be pretty sweet to give to our data science team something to work with. There you go. Like you get it from the DB, get it into Kafka, and then after that, you can do whatever you want with that data. That's pretty neat. So
yeah, I've found it also helps with kind of like pulling people's minds out from all of the low level stuff, because you actually have to think about like, well, what are the schema of my events? What are the semantics of them? How does all this work on like a system-wide scale, not focused on my little service and whatever API I can produce for it.
Yeah.
Because I feel like a lot of times people just get stuck thinking about like these low-level tools that they have, and they don't kind of explore other things that might exist, or even question if the tools that they're using are actually like the right tools for the thing that
right
they're
tool.
trying to do.
Yeah. Microservices in general, like, microservices,
Go ahead.
you would think that making a microservice architecture would allow you to think very small in terms of scope, but it's actually the opposite, because you have to now coordinate messages or schemas or whatever across several services. So now you actually talk more to your coworkers in a microservice environment than if you were all working on one giant monolith. So I always found that to be an interesting, unexpected result of just working in a distributed system.
Yeah, I was gonna say earlier, as like a little bit of an unpopular opinion, that I think we should stop trying to encode human communication into Git flows, specifically Git flow as
I love that.
like
I love that.
In general, like have people talk to each other instead of trying to be like, well, here are these 35 different branches, and if you want to communicate this thing, you use this branch with this name, and then it get merged in at this point in time, and that means that this thing has happened. I'm just like, can you all just like talk to each other or something? Like this is no one's gonna understand this.
Totally agreed. I think that there's definitely, well, everyone now is doing remote these days, like, but I don't want to do like a hipster thing and be like, oh yeah, but I used to work remote for a long time before, back in the day. But part of that, like, so the culture, like written culture, is totally an amazing thing. But it's the same thing as with all things. Like you can have like almost too much of it, right? Like having these crazy processes, like what you just described, of having different branches and create different issues and different repos and so on and so on. It just gets too much, and you just simply should just talk to somebody as well and use your brain. I mean, getting paid to be a software developer, use your brain and realize that maybe this is too much, right? Like the cognitive load of literally just doing like, one thing to just talk to someone versus having to fill out 6 forms and so on and so on. So, but with that said, still need to have a written culture.
Yeah.
Just saying.
Write things down. Please write things down.
I'm going to take us off air, if that's fine with everybody.